Today we're diving into something, well, kind of wild. A theory that claims you can get all of physics, and I mean all of it, from the mass of an electron to the force of gravity, from a single number. So let's talk about the 255-degree universe. All right, let's just jump right in with a question that basically flips physics on its head. You know, we're all taught that physical laws work locally, right? Like particle by particle, moment by moment, building up from the ground up. But what if that's completely backwards? What if the laws aren't local at all? What if there's one single grand rule for the entire universe, applied to its whole history all at once? In that one question, it leads us to a completely different way of seeing things. It's called a global constraint framework, which is just a fancy way of saying, instead of rules bubbling up from the tiny stuff, what if there's a master blueprint for the whole cosmos from the get-go? So yeah, this lays it out perfectly. The standard view, the one we all learn in school, is bottom up. You figure out the rules for quarks and electrons, and the universe is just what happens when you add all those tiny interactions together. This new idea, it just flips the script. It's top down. It says there's one big rule for the whole show, past, present, and future, and every single particle has no choice but to follow it. So what is this master rule? It's called global phase coherence. Okay, stick with me here. Think of phase like the beat of a drum or the swing of a pendulum. Now imagine every single particle in the universe is its own tiny pendulum. This rule says that no matter where a particle goes, what path it takes, its swing, its rhythm, has to stay perfectly, absolutely in sync with everything else. The whole cosmic orchestra has to play in perfect time. And this whole idea of a universe staying in tune, well, it's not just a nice metaphor. It's the foundation for a real specific model called modal theory. And this is where we go from a kind of cool, abstract idea to one very specific, very shocking number. This, 255 degrees, that's it. According to this theory, this one number, this specific angle, is the geometric lock that holds our entire reality together. It's the key in the ignition for the cosmos. And the actual core of the theory? It's almost ridiculously simple. You start with just two basic fields that fill all of space. Think of them like two invisible fluids. And they're interacting. But the magic, the real trick, happens when the phase difference, that rhythm between them, locks in at exactly 255 degrees. This weird off-kilter angle is supposedly the thing that breaks the perfect symmetry of the early universe. It's the flaw in the diamond that lets the light in, that lets all the complexity we see emerge. And that leads us to what is, without a doubt, the theory's boldest claim. I mean, look at this quote from its author. Our current best theory of physics, the Standard Model, has something like 19 free parameters. These are numbers we just have to measure and pluck in by hand. We don't know why they have the values they do. Modal theory claims to have zero. None. Everything it says just falls out of this one geometric fact. But, okay, let's be real. That's the big question, right? How on earth do you get, well, everything from just one angle? It sounds kind of crazy. The theory says it's like a cosmic domino rally, that one 255-degree lock tips over the first domino, and that sets off a chain reaction that builds our entire reality. And here's the supposed domino effect right here. It all starts with that phase lock at 255 degrees. The theory claims that instantly causes something called baryogenesis. That's the super important reason we have a universe of stuff, of matter, instead of just an empty void where matter and antimatter canceled each other out. Okay, so from that, the geometry then supposedly spits out the exact masses of all the fundamental particles. And from there, it predicts the exact amounts of hydrogen and helium created in the Big Bang. It's just one thing leading to the next, to the next. And this isn't just talk. It leads to actual hard numbers. Take a look at this table. On one side, you have the value calculated by modal theory. On the other, you have the official lab-measured value. I mean, look at the electron mass. Look at the top quark. They are incredibly close. So this isn't some vague philosophical idea. The model is making really precise, testable predictions. And it just keeps going. The claims get even bigger. The theory says it can derive the core equations of quantum mechanics, like the Dirac equation. That the rules of chemistry, why atoms bond the way they do, that's just a downstream effect. Even gravity gets a makeover. It's not about curved spacetime anymore. It's just spacetime bending and twisting just enough to keep the whole universe in tune.
Okay, I get it. This whole global rule thing can sound pretty out there, pretty abstract. But what if I told you we're seeing something weirdly similar happen in a field we're all hearing about constantly right now? I'm talking about AI.
So in these big AI models, there's this thing called an attention mechanism. It's how the AI figures out which words are related to which other words. And here's the wild part. As the AI trains, these connections start to organize themselves. They form a kind of internal geometry, all on their own. It's like the AI is naturally building a structured map of ideas inside itself. And then comes the punchline. Researchers tried adding a simple, global rule to the AI's training. Basically a rule that said, hey, keep your internal map consistent. And what happened? The AI got way better at solving tough new problems. A top-down rule made the bottom-up structure smarter and more robust. It's an almost perfect analogy for how a global law could shape our universe. So, okay, the numbers line up pretty well. The AI thing is a really cool analogy, but this is science. And in science, that's just not good enough. The only question that really matters is, can you test it? Can you prove it or break it? So let's talk about taking this from paper to the lab. And the answer is yes. The theory makes some seriously concrete predictions that we could test, like right now. First up, it says you can build a 10-centimeter device that manipulates these fields and produces a measurable force, a tiny but real physical push. Number two, it predicts that gravitational waves have these tiny echoes in them, little phase shifts that our giant detectors like LIGO could start looking for, maybe as soon as 2027. And then there's this wild practical one. You could create additives for materials like concrete that make them stronger by basically aligning their matter with this universal coherence. You know, what's just as important as making predictions? It's telling people how you could be proven wrong. That's what separates real science from pseudoscience. And this theory, it lays out exactly how to falsify it. It gives us a checklist for its own destruction. So, how does it fail? Well, the theory is dead in the water if we find out that those fundamental constants can actually change. It's totally wrong if we can build a perfect quantum computer that's completely cut off from the rest of the universe. And, maybe most importantly, if we build the experiments to look for that physical thrust or those gravitational wave echoes, and they're just not there, game over. The theory fails. So that's where we are. We have a theory that is either spectacularly wrong, or it's one of the biggest insights into reality we've ever had. It paints a picture of a universe that isn't just a random collection of local events, but one that's guided from the top down by one single beautiful geometric rule. The experiments are possible. The predictions are clear. So I'll just leave you with this to think about. What would it mean? What would it change if it turned out to be true?